I'm good. I'm good. Chill. Megan, you weren't even here on Friday. No, you guys' internet's just bad. It's not my fault that for you I'm behind, but for me, I think I'm actually early. For me, I started this at 12:44. Yeah, just turned 12:45. So you guys are, yeah, I really want to check your internet connection. Nope, I used the atomic clock. No problems there. Yeah, Megan, I want to hear from you. That's 2 days last week that you didn't even show up to class. So, me tardy? Nah. Let me guess. You were in the bathroom with Cassidy. I was tanning. I'm done. At Weatherby Lake. All right. Megan, we get it. We already established last week or the week before, we know you're rich, okay? You don't have to keep throwing this in our face. Right? We understand that you own your own boat and your own lake house. All right? But for the rest of us people, we're just commoners trying to learn math through Twitch, just grinding out the days. Right. I also have friends, so ha. Of course, Matt, what are you doing? We were trying to have a united front against Megan here, and now you're gonna turn on me like this? This is what she wants, all right? She wants to divide us. We have to stay strong, okay? Don't let her get in your head. Okay, nice. Well, Megan, I can assume that you watched the video from Friday, right? So you know what mathematical induction is already? Did. All right. So we're good to go. I believed in you. I assumed you would. Maybe you're lying, but I was hoping. All right. Cool. So remember, for mathematical induction, it's all about the domino effect. That's my name for dominoes. Perfect. All right. The idea is if we can prove that one domino will follow, the first domino will fall over, and then we can prove if we know some domino falls over, will the next one fall? Then we can, without even having to actually see the dominoes fall, we know, well, yeah, if I push this one over, the rest of them are going to fall too. All right, that's kind of the informal way to think about it. But we also have this wonderful steps that we do. Okay, kind of broken down into 3 main steps. Step 1, prove it's true at the most basic case, so we'll plug in 1. Step 2, all right, we know it's true for 1, so let's just assume it's true for some random k, doesn't matter what. Can we then prove that it's true for the k plus 1 term, which would just be the next term? And if we can prove that, then it starts like a chain reaction, like the dominoes falling, to prove that all of them, or it'll be true for every natural number. All right, so we did it for these two, which were all about basically like partial sum formulas. Okay, so let's move on to our next process, which is not about proving what the sums of things are, but rather if proving things are divisible by a certain number. Okay. So prove by mathematical induction that 5 to the power of n minus 1 is divisible by 4 for all natural numbers n. Okay. Let's try it out. So we just have 2 of these to go through today, and then we'll be good. So step 1. Okay. This is where we ask ourselves, is it true at the most basic case for when n equals 1? So 5 to the first power minus 1. So that's 5 minus 1, which is 4. And 4 is divisible by 4. You might not know that, but it's true. Okay, so yes. Let me put a yes because I'm excited. Okay, yes, it's true at the most basic case if we plug in 1. All right, that's the most basic, simple natural number. All right, and natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, etc. Okay, great. So now we can move on to our next step. Give me green. All right, step 2. So we assume the statement. We assume it is true for some n equals k. Right, so that means 5 to the k minus 1 is divisible by 4. Okay, now we're going to do something a little bit different with this. So instead of just saying, usually in this step, like what we did was say, okay, it's true for n equals k, so we just plugged in k. Or step 2 over here, we assume it's true for n equals k, so we just plugged in k. The difference over here with this one is we don't have an equation. We just have, it's a property. We're saying this thing is divisible by 4. So I don't really have like an equation, but I can make one. So here's what I'm going to do. What that means is if I do 5 to the k minus 1, right? If something's divisible by 4, that means it's 4 times something else, right? 8 is divisible by 4 because it's 4 times 2. Right? 32 is divisible by 4 because it's 4 times 8. Or 48 is divisible by 4 because it's 4 times 12. So it's just a matter of what is the number that's being multiplied by 4 to create this number. So since we don't actually know what this number is, right? We're not saying a specific number. We're just saying whatever it is, it's divisible by 4. So we're going to write it's equal to 4 times something. Or we'll call it P. Right? So this, what I have in red, is the same thing as saying 5 to the k minus 1 is divisible by 4. Because I know whatever it equals, it's equal to 4 times something, which is what it means to be divisible by. Okay, so now let's go to step 3. So we want to now prove it is true for k plus 1. All right, so let's consider 5 to the power of k plus 1 minus 1. And here's where we're going to have to do some real good manipulation here. All right? Think of your most manipulative friend, and you really want to channel their energy whenever you are doing this problem. Okay, because you're going to need it. one thing that we did in the in our sequences and series, 5 to the k plus 1, I can split that up as 5 times 5 to the k. Right? Remember, whenever there's an exponent and there's addition in the exponent, we can split it up into 5 to the k times 5 to the first. So that's all this is. This is 5 to the first, which is just 5. And then times 5 to the k. All right, that's just exponent properties. That's back to algebra 1. Okay, now we have to have a real stroke of genius here where I say, actually, instead of 5 right here, I'm going to write that as 4 plus 1. Okay, just that first 5, I'm going to instead rewrite that as 4 plus 1. Now, that seems very random. Why would I even do this? Okay, it is a bit random. It's just kind of a trick we have to consider. But remember, we are trying to prove that things are divisible by 4. So somehow in all the math I do, I'm going to need to end up with some 4s somewhere, right? So what this does that's helpful is it introduces a 4 into the problem, right? So we're going to use that. From here, I'm just going to do some good old distributing. Right? So 4 times 5 to the k. This keynote, this would not create 20 to the kth power. Right? That is not valid. Okay. So 4 times 5 to the k. Plus 5 to the k times 1, so plus 5 to the k, and then minus 1. It's your favorite week of the year. Would that be your birthday week? Okay, now, remember what we did back in these problems. We used our stuff from step 2, right? We ended up substituting in to the equation. We're going to do that same thing here. In step 2, I said, hey, I already know, I'm assuming this stuff is divisible by 4. Right? So when I look at this thing, 5 to the k minus 1 is 4p. Well, check it out. I have a 5 to the k minus 1 right here. Okay, so 4 times 5 to the k plus 4p. Not only is it my birthday week, tomorrow's Cinco de Mayo. True. Today is May 4th, which means Star Wars Day, and Miss Hall's boyfriend, his birthday is today. Then tomorrow is Cinco de Mayo and my birthday eve. And then the next day is my birthday. Now, that's very nice. A legitimate question I have is, well, maybe Cinco de Mayo. I don't know. Do you guys like celebrate Cinco de Mayo? Is this a big deal in your family, in your household? And then also, how much does Miss Hall's boyfriend's birthday really affect your life? Like, it seems a little odd that maybe that's like playing into your favorite week. Like, I don't, maybe. That's great if it does. I'm happy. We love any excuse for tacos and margaritas. Sure. Okay, so now that I've substituted in 4p, because we had 5 to the k minus 1, which is from step 2, now look at both of these terms. 4 times 5 to the k added with 4p. They both have a 4 in them, so I'm going to factor out that 4. So 4 times the quantity of 5 to the k plus p. this is exactly what I wanted to show. Because what I've shown is whatever this number was originally, 5 to the k plus 1 minus 1, actually I can rearrange that so that it's in the form of this stuff times 4. And so like we just mentioned, if I can rewrite a number as some number times 4, then whatever I get from that means it's divisible by 4. Right? So we've proved everything we need to prove. Okay, so here's what we write. And we write our triangle of dots, which just means like therefore. So by the principle of mathematical induction, 5 to the power of n minus 1 is divisible by 4 for all, that's not how you spell natural. For all natural numbers n. Or if you wanted to be super fancy, you can write it like that. That pink, that thing that I have underlined in pink, you could also write using these symbols. So it takes a bit of trickery in here of first splitting up the exponent, 5 times 5 to the k, and then rewriting that 5 as 4 plus 1. That way we could have a 4 introduced. Doing some distributing, rearranging, substituting. We always have to use whatever we had in step 2. Step 2 is always a very important part because we always bring that in for some sort of substitution, which then allows us to make our final conclusion. Okay. Next up, prove by mathematical induction that n cubed plus 2n is divisible by 3 for all natural numbers n. Okay. Step 1, start with the most basic case. All right, we want to know, is it true for n equals 1? So 1 cubed plus 2 times 1. So 1 plus 2 is 3. 3 is divisible by 3. Okay, so it's true at the most basic case. We've proved that first domino will fall down if we push it over. Step 2, now we want to prove if we pick out any domino, can we assume that that's true for it? So we assume it is true for n equals k. All right, so what was our expression? N cubed plus 2n. So, but plug in k, so k cubed plus 2k is divisible by 3. Now, how can we write that mathematically? So that just means whatever this number is, it's equal to something, and we'll call this something p, something times 3. Right? That's what it means to be divisible by 3. Just going to move it down a little bit. Okay, for some p, who knows what it is? We don't really care. I already used red. Let's see something else. Okay. So step 3, we want to prove it is true for the next domino, the next term, n equals k plus 1. Okay, so let's start with our expression. Instead of k cubed, right, instead of k anywhere, we want k plus 1. So k plus 1 cubed plus 2 times k plus 1. Right? K plus 1 cubed k cubed plus 3k squared plus k. Oops, why did I put cubed again? Plus 3k squared plus 3k plus 1. Okay, now doing this, the way that I just did that was I just used our binomial expansion. Right, that's Pascal's triangle. I don't know if you guys can see that one. Right, so this top row, n equals 0, n equals 1, n equals 2, n equals 3. Right, so when the exponent is 3, the coefficients are 1, 3, 3, 1. You can see that's exactly what I have, 1, 3, 3, 1. And then doing that pattern with the powers of the first thing starts and goes down, 3, 2, 1, k to the 0. The second term starts at 0 and goes up to 3, so it's just 1, so it doesn't really matter at all. But that's how I did that. All right, helps to know that so you can do things quickly. Distribute 2k plus 2. Let's combine some like terms. So k cubed plus 3k squared. All right, that doesn't change. Actually, I'm not gonna, hold on. I'm not just gonna combine like terms. Because remember, our goal in this step is that we rearrange stuff until we can make a substitution from step 2 down into step 3. Right, that's what we always do. Use a substitution from step 2 down into step 3. So I want to rearrange stuff until it looks like step 2. So in step 2 we decided, hey, k cubed plus 2k is the same thing as 3p. Well, look down here. I have a k cubed and I have plus 2k. So let me rearrange that actually. So k cubed plus 2k. And then I'll just leave all this other stuff. So plus 3k squared plus 3k. I'll go ahead and add the 1 and the 2 together, so plus 3. Now the good thing about k cubed plus 2k is we already decided, hey, that's the same thing as 3p. All right, so let's make a substitution. 3p plus 3k squared plus 3k plus 3. And now, again, look at all these terms. They all have a factor of 3. Oops. So I'd get 3 times the quantity of p plus k squared plus k plus 3. which all of this together is just some number, which then gets multiplied by 3. That's exactly what we want, because that is like that's the definition of being divisible by 3, is can we rewrite it as some number times 3. So we've done it. So by the principle of mathematical induction, n cubed plus 2n, is that what it was? N cubed plus 2n is divisible by 3 for all natural numbers n. Or again, fancy version would be that.